That's an invalid question. There are no dumb questions, but that's an invalid question because the answer is in front of your face. Bonjour. Yo me llamo es Miguel. No hablo. I don't know how to say French in Spanish. Asian gaming speaking francés. No hablo francés. Lo siento.
I don't know how to say
One of the most important phrases to know if you're going to go to a Spanish-speaking country is lo siento, means I'm sorry. Or, donde están el baño is pretty important too. Where's the bathroom? If you're going to go to a Spanish-speaking country, you should probably know how to ask where's the bathroom.
I told him where it was.
What? Who? Right behind up there. Keeping it right beside him. I don't like to separate things because then something can like get lost or whatever. So the fact that I'm going to keep the box, I'm going to keep it close to it. All right, peeps. We have a lot to cover, and everyone should be here by now. So for our friends who are late, so sorry for them. They will just miss things. So your homework, exactly what's in the box, and you don't need to write anything else. You don't need to write the word homework. You don't need to write HW. Now, when you head your paper, you need to head it appropriately. A lot of us are having issues with properly heading our paper, and we're trying to take the easiest way out. Right now, I'm still being forgiving on that and not like making that impact your grade. For those of you who did not turn in your homework, right now you either have a check, minus, or a missing if you did not turn in all those assignments, and that is in math right now. So if you go check math, now when we post grades in math, there's two different grades. Do you guys understand the difference between the two types of, like, the two different grading in math? One is academic and one is effort. Hey guys, you're late, so when you come in, do it quietly. So the academic grade is literally like you based off the standards and what you were supposed to do. The effort grade, guys, I got a lot of people not paying attention. You're going to want to know this. The effort grade was, did you turn it in on time? Was the work quality what we were expecting? Did you have what we told you to have on there? Like when I tell you exactly what headers should have? So right now, my grading is strictly academic. Did you do it? The effort grade, even if you turned it in late, I did not put a late mark or like anything like that on there. However, as we move forward, it will. Like, it will matter. For homework collection tomorrow, I will be collecting 115, 121, and 122. So just 3 homeworks this week, not 4. I don't know that we'll have another homework tomorrow. And here's the deal. I want everybody listening right now, so give me your eyes. Even if you're in the middle of something, give me your eyes. I would rather, and I can't speak for the other teachers, but most of them I think feel this way. I would rather you turn something in late than turn it in not done. Because if you turn it in not done, you're effectively saying, I'm done working on this, even though I know it's not done. You keep it and turn it in late, that means you cared enough to put in the effort to get it where it needed to be for the assignment. And on the your effort side of things, if you turn it in partly done, you're gonna have to finish it. So you're just gonna waste the amount of time that it sits in my bin and gets graded and then gets handed back to you for you to then just have to finish it. So if tomorrow, this is the long story short, if tomorrow you don't have 122 done, don't turn in your homework. Don't turn in anything. Now you should have 122 done by tomorrow, and like I'm gonna try to grade them over the weekend, get grades in quicker. But like what I collected Friday, that's in math now. So when you go to AO, check math. If you have a check, minus, or a missing, come see me. Talk to me about what the deal is. I'm gonna give everything back tomorrow because we're gonna cover books and everything tomorrow. So as you see on the chalkboard and the smartboard, please everyone bring your book tomorrow. Some of you have left it in this classroom. That's totally fine. Some of you have taken it home or have it in your locker or whatever else. Bring it back tomorrow. We are covering your books so that then you can decorate them and whatever else, and so they're protected, so you don't end up having to pay for them. So yeah, we will all cover our books, just like this, and then because you're all more creative than me, you can decorate it however you want. So we had covers last year that were literally entire Sharpie, like the whole thing was Sharpie. Yeah, and better than the stretchy covers, if we haven't talked about this, the stretchy covers you cannot Sharpie on, it'll bleed through, and then you'll have to buy the book. So I don't know if I announced that in this class, but that's why we don't use the stretchy covers. Oh, my TV's not on. That's why you guys can't see anything. It helps if you turn it on. So, yesterday we ended right in the middle of 1-2-1, so you can go ahead and pull those notes back out if you want. We had just been talking about these fractions, right? The 2/7 chance. Here, I'll pull this down onto the big screen. The 2/7, 5/7, 8/7. We talked about these, yeah? No? I mean, I'm seriously asking because okay. What was wrong with one of these fractions? If we're talking probability, what was wrong with one of these fractions? Evan?
Steve.
Why?
Because it's more than 100%.
Because it's more than 100%. It's more than 1. In your notes, everybody write the word probability and then draw a line. Why do you... Oh. No, today's Wednesday. This should not have stuff written here. What? Today's Thursday. Yeah, I just clicked on the wrong box.
That's even better.
That is better. We're closer to the weekend.
Exactly.
So, probability. Probability.
Isn't it 2019?
No.
No. It's 2018.
You just gained like a whole year of your life back. Then, line. Now you can put arrows on the end, and the textbook actually puts arrows on the end, but what we're going to care about is from 0 up to, where does probability end? What number represents 100%? 1. Because remember yesterday we talked about that 7/7 fraction? So what word would we use above 0? What word would represent the probability of 0? Ava? No is actually a pretty good guess.
What?
You said no, don't call on me. And no would actually kind of be a word that works. Yeah, but what word means there's a 0 chance? We talked about it yesterday. Eva, I think I just heard you say it. Impossible. Man, I might be sick. Sorry, I'm going to keep my distance from you guys. Cover myself.
I don't want to get sick.
What word would go over top of the 1? We talked about this yesterday. You guys figured out some events that they for sure will happen no matter what. I think we got a little morbid and we said one day we will die. Well, in every class we ended up making it to like, yeah, I mean, mortality, that's certain. Yeah. Certain. And anything in the middle is uncertain. So in your homework, you were asked to place different probabilities on the line. This is just the distance between 0 and 1. So right in the middle, what chance would that be? 50%, which a lot of times you hear people talk about as a 50-50 chance. What that means is there's a 50% chance it will happen, 50% chance it won't happen, which is like Ohio winter. It might happen, and it might not.
True. You were like the best math teacher I've ever had.
Well, thank you. I try to make it entertaining.
All my other math teachers are like, here's this, go.
If you're not going to like math, I at least want it to be entertaining. You know what I mean? Like, I don't, so,
I love
all right.
the clock.
Yeah, well, that and that. That one just says digits of pi. That one's more
That's
interesting.
pi, right?
And this one, I don't think it's on. I think I need a new battery. Like, I don't think the time is right. It's
A little bit off.
at least an hour. No, I think I need a new battery. So what would be in between 0 and 50%? What chance would be there, right between 0 and 50? 25% though, right? And we actually yesterday talked about we don't really use percents for probability. So what fraction would be between the 0 and the 50-50? Eva?
25 over 100.
Yeah, let's reduce it. Let's be simpler. I don't want to write that much.
1/4.
1/4. What up here closer to certain? If we go between the 50 and the 100, what fraction would be there? Anybody? Yeah, what fraction? 3/4. Right, so if you get something like 7/8, which I think, yeah, we, no, 5/7, or, yeah, sorry, if we flip C over, we look like 7/8. That's almost 1, right? So those sort of really likely things are up here. It's not certain. I gotta have some. I just really need to drink something. It's not certain, but it's probably gonna happen. And then, like, if you're going to the casino, yeah, you're down here. House always wins. Like, your chances of winning at the casino are very, very small. Might happen, and that hope is what keeps people coming back, but probably not gonna happen. So, when we talk about probability, and if we're gonna talk about the casino, one thing you might gonna do is play roulette. Now, roulette is actually not that bad of a casino game. If you don't know what roulette is, I will show you very quickly, but then we're going to make our own version of roulette. No. I wonder if our firewall will let me go there.
We're actually going to play roulette?
No. So, a roulette wheel. Here, give me your attention, please. Yo, hey, up here, I'm trying to teach you how to make money now, not just make your life easy. Now, full disclosure. The odds are not in your favor. If we talk math, you're going to lose. Okay, now, but there is a chance you could win. So a roulette table looks like this, but a roulette wheel looks like this. What do you notice about this? And actually, I'll try to find a better version of the image. Sorry. I type really fast sometimes. Wheelie. Here, 1,000 by 1,000. What do we notice about this? Hands. Who can give me some observations? Aiden?
It has one zero at the top, and it has 2 zeros with a dot at the bottom.
And those are both greens.
Yeah, they're green.
Right?
Does that mean you win $0?
I'm struggling with your name this morning. Riley. I don't know what. I know Maria's in the afternoon, but for some reason I was trying to call you Maria. Riley.
When it does the spinning, it lands on one of the numbers.
Yeah, so this little ball, you spin the wheel one direction and you spin the ball the other direction on a little track above it,
Don't ask
and
how I know that.
then the ball will randomly fall into the wheel somewhere. Sky. Hey guys. We're having a group conversation, and a lot of you are having your own independent conversations. Join us, please. We're trying to learn something, not just talk about things, but I'm leading you there, right? I'm not trying to just put something in front of you and say, write this down, memorize this. I want you to know, like, what we're really talking about. You don't count up all the spots. Or, I mean, you can look at the numbers and kind of make some inferences, maybe. I mean, you tell me. I see 4. So even and odd, that's like for black. Is there a black 23 also? I see a black 24.
I think they have like around 40.
There's 38.
Sky?
Like what I was saying was there's like a black 24 and then a red 25. So they kind of like.
They kind of like alternate maybe. So we are going to make our own version of a roulette wheel. Yeah.
Is there money
So
involved?
everybody on your notes, draw a circle. Now I'm going to cheat. Sorry.
Is there money involved, Mr. Hudson?
What? Are you kidding me?
Now, me, slightly OCD, especially back in high school taking notes. If you want to draw a circle in your notes and a non-perfect circle is going to screw you up, a lot of you have water bottles. Trace your water bottle.
Oh yeah.
But it's not a perfect circle. Mine's
So, if this, hey, making a circle does not take your mouth. If this was our roulette wheel,
Can I trace my lips?
and I say you win on green, right? Because green won yesterday. What's your chance of winning here? 25%, right? Now, I bring out a different roulette wheel. And I say, you win if you land on green. What's your chance now? Now let's talk fraction, right? What's your chance fraction-wise? Sky? 1/5, right? Your task. 20% then, right? When we convert to percent. Your task is to create your own roulette wheel at your group, and you don't have to call it a roulette wheel if you want. I just thought that'd make it more interesting. That has these probabilities. Crap, where'd it go? This. Make that happen. So you designed it at your table. Now, I'll take this challenge a step further. First group to actually show me their design and why it works gets to actually make it.
I want to make it.
Well, then you have to do it in your notes first. You have to be able to show me your design and why. Remember, we have colored pencils and markers right over there. If you want to grab it, you can also just write in the colors if you want, but if you actually want to be colorful, colored pencils and markers. I'm going to give you guys I'll probably give you about 5 minutes. Should be plenty of time.
Okay, so.
Sorry, I got to back out if you're going to be able to answer the questions. Actually, Ava, you might be mad at this, but I'll put one more caveat. If your group wants to make the spinner, you have to have the spinner in your notes and the questions answered. A through E. That's what we're working on right now. It's not too hard. It's all about effort. How much effort do you want to put in? It does. I can't tell how many wedges are there. Anyone can see. Will splitting my wheel into fourths work? No, that doesn't really make any sense.
Yellow and the rest of green. So, remember give me red, yellow, blue, green.
What happened to your legs?
They're temporarily
If you're ready, if your wheels are divided, I think they're the one who's going to get stuck.
Putting purple, green.
How many wedges are you trying to make?
Oh, wait.
4? So you're just going to guess on the size of like 40% versus 30% versus 110?
Just stand on the
So
side of my
I
leg.
think we made more than 4. I know there's only 4 colors, but I think it's easier to make more. Can anyone tell me how many wedges they're going to make in their wheel and why?
10.
Okay, Riley, why 10?
Okay, because it says right there next to yellow, 110. So, yeah,
If 1/10 will be yellow, that kind of tells us a nice way to cut a wheel apart. Because then how do I make 40%? 4/10 or 3/10 or some amount of tenths. So splitting your wheel into tenths is a good strategy. Good. Keep going and answer those questions. Once you get your wheel done, answer those questions.
Grab a yellow.
No, I don't know if these pieces are actually I don't know if these actually got put away correctly. You have some already out there. I don't know if they got put away correctly. Here's some of those. Now, if we're looking for specific colors, remember the giant thing of colored pencils? You can just grab specific colors. You're coming up here. Who can talk me through figuring out how many tenths green gets? Who that isn't Riley? Sorry, Riley. Labiba, help me out. How do I know how many tenths?
It would be, once you fill in all of them, it would be two triangles.
Because if I say 4 and 3 more and 1 more, I got 8. I need 2 more. Yeah, we should use cards. Jalen, where are you even sitting there?
Right here.
Hiding behind you. Jalen, what color is most likely to be the result of our spin? Why red? It's the biggest fraction, right? 4 tenths is bigger than the rest. Red is most likely. Alright, if we are not done making our spinner yet, we need to wrap that up in the next 30 seconds. It has been over 5 minutes. We were just coloring in a circle. Sophia, what's the least likely result? Why? Smallest fraction, right? 1/10 is the smallest fraction there. Yellow is least likely to happen. And it's the smallest region. You can also just look at your spinner.
Okay, I'm done.
Now, if we pay attention to our homework and what we talked about yesterday, theoretical probability means we don't actually do it, right? So, how do we write the probability of red? If you can remind me how we write the probability of red. Ava?
So you count all of the parts of the circle, and then you take the how many reds you have, and you put it as your what is it called?
Numerator? Denominator?
Denominator, whatever.
So how do I write this though? What do I write first? I'll give you a hint. I'm going to start with P.
Oh, never mind. Don't worry.
So we did this in our homework. It's concerning if you don't know. What comes after P?
But okay, so P and then it's a parenthesis.
Yeah.
And then isn't it like red?
Yeah, the word we're looking for.
And then another parenthesis, and then how many there is?
So here I would put 4/10. Or that could even reduce to 2/5.
And then take that. Or well,
It could go up to percent. So please finish up your wheel and write down a couple of these using proper notation. Probability of red is 4 out of 10. P of blue, or probability of blue, is 3 out of 10. And we write these as the fraction. Sorry, when I get low on the board, my writing gets messy. So I think everyone figured out splitting our spinner up into 10 regions was easiest. Now, if you're really good at approximating how much of the circle that you took, you wouldn't necessarily have to split it up into 10. But I always would advise using the least common denominator, or the lowest common denominator, which in this case is 10. We cannot really use a fifth. Now we're gonna probably have to skip over this just because we're short on time and I have a certain amount of stuff I want to get to this week at least. So just again, reminder, if we wanted to actually test this, we could make spinners. Now the spinners would have to be fair, which really the best way to do that is use a computer. So if you want to do this, go back to the ebook in the lesson and click on the 154 student e-tool. You can play around with making spinners. And you can like quiz your friends or whatever else that can be helpful for you. But theoretical means you just look at it, right? We make those predictions. Everything we just did was theoretical because we didn't actually spin the spinner. If we wanted to test it, that would become experimental probability. Okay. If you need to write this down to remember that, please write down, like, if we spin the spinner, that's experimental probability. What we find out from that. Any other questions from 1 to 1? With that lesson, I want to make sure our foundational understanding of probabilities was good. Yeah.
Is that it?
That's the basics of probability, yeah. But it gets much more complex, I will warn you. Ba-dum-bum-bum. All right, squiggly in your notes. You don't have to start a new page unless you need to start a new page. But squiggly across to split your line or split your page, or you can do straight lines if you want. The squigglies kind of stick out more. In your notes, we're writing 1.2.2, just so we're aware that we're moving on. And this is investigating, and I won't make you write out all of probability.
Do we get to make a new one?
New one what? What do you mean?
Like a new spinner.
We're running out of time for that. Anybody feel like reading?
Me.
I'm just gonna have to draw.
Oh, dang it.
I haven't feel like reading.
Me?
Yeah, feel like reading. Sure. Start with, have you ever tried?
Have you ever tried to predict which football team will win a big game? If so, you probably did not just pick the team with the coolest colors or the neatest mascot. You may have days to pick on statistics and statistics about win, loss records, player injuries, and other data. Knowing what has happened in the past can sometimes help you predict what will happen in the future. In this lesson, you will use data to make predictions. As you work with your team to uncover mystery spinner, keep the questions below in mind. What is the probability in or likelihood? What do we expect to happen? And how does the actual event compare to our prediction? What do we know?
Yeah. So, predictions are just that. They're just predictions, right? They're like guesses, hypotheses, whatever other word you want to make for it. But, using math, we can make our predictions a whole lot more accurate. So they won't necessarily come true, but if I know that the Buckeyes have beat this team and that team and that team and that team and all these teams are better than this other team, I can pretty much use math and say the Buckeyes are probably going to beat this other lesser team. There might be a fluke. Kicker could get injured, who knows what happens. But if I use math, I can make better predictions. So, we have a mystery spinner. Your challenge is to perform an experiment that will allow you to predict what the spinner looks like without ever seeing it. So we're going to have to collect some data, right? So statisticians, like Ivan just said, statisticians are people that collect data and then spit it back out to somebody with, like, here's what this data means. So, now I should have an e-spinner, right?
I mean, we're on 1.3.1. No, we're on 1.2.
1, 2, 2.
Oh, oopsies.
I lost my e-spinner. There we go.
No, it's not.
All right. Check it. Here is our mystery spinner. As we click it, it will spin and tell us what the result was. So we don't get to see it spin. So please, in your notes, label like one, what question was this? 63. And give it the title Mystery Spinner. And then we're going to keep track of the results. Now I believe you can just use the first letter of each color. So don't write out purple, just put a P, then put a comma. Or, actually, better idea, this might work well, we can use tallies if we really want to make our life easy. So you have Mystery Spinner. Yeah, my smartboard pen got a little weird there. Yeah. Purple, and under that we can keep tallies. If we have like orange or blue or red, I have no idea. But as we get colors, just make new lists. Keep track.
So
So last week didn't we turn in 1.4 and then from below?
Yeah, 115 is
Okay, so
this week.
1.5, 1.2.1, and 1.2.
Those three are what I'm collecting tomorrow.
Where I'm blind.
Alright, again, if we haven't made this formal announcement, this is the always homework board. So regardless of where the smart board ends up being, and like we can't see the homework now, right here. Purple, got it. One purple. Spin it again. Green. Got a green. Spin again. Get another purple. Two purples, one green. I need you with me. Spin again. Except my cursor.
Maybe we get purple again. So you're getting purple. So we got green, purple, green.
Green. Because it should, the border changes yellow really quickly. Green.
You're getting infinite.
Purple. Purple. So, yeah, wait, what was that question? Say a lot of purple. At this point, I mean, that's all that we've gotten, right? So we might think it's just green and purple. Let's keep spinning. Another purple. Another green. Another purple. Ooh, orange. There's orange. Now, how many spins have we spun? Somebody count up our total.
11.
11. Ooh. Probability over 11. Do we want to stop here or keep going? Keep going. Where would be a good amount of total spins to stop at? Sky? Why 20? It's even. It's a 10, and I could easily turn it into 100. Right? So let's keep going. Purple. Spin 13. Green. Spin 14. Purple. Spin 15. Green. Spin 16. Green. Spin 17. Orange. Look how excited we get when orange comes up. I forget what number to spin, but green. 18. If this one's 19 then. Spin 19 is purple. Spin 20 is orange. One last orange. Woo! All right. I need you guys at your teams to figure out the percent likelihood of each color, and then sketch a quick what you think the spinner looks like.
Oh gosh.
Like, you don't need to actually color it, just write the colors in. So first, figure out the percent chances, then sketch a quick what you think the spinner looks like. Did you see me like just about totally mess up? I thought that tab was the E thing, but the tab switched places. You might have missed. Do we have 20? Ava thinks I miscounted. Okay, how many purples did you have? How many? 9? They had 9 purples.
I had 9, yeah.
Okay,
We had
how
9
many
purples.
greens?
9 green, and then 3 oranges.
9, 8, 3. I think is what the numbers came out to be. Is what people are saying.
No, there was only 3. It was 9 and
I have 6.
it was 9, 9, and 3.
That math won't work. It has to be 9, 8, 3 to be 20.
Yeah.
Or something, or
No, the
like
green-
we
the green
miscounted
was
something.
8. There was only 8 green.
Yeah.
Yeah, 9 purple, 8 green. I'm about to write this down up
You
here.
said 9, 9.
8. Yeah, exactly.
Yeah,
9 purple, 8 green,
Yeah.
3 orange.
Yeah.
So,
Like, totally. On point. Yeah. We're like,
I have effectively lost 2 lessons this week. That and, tomorrow's class is going to be slightly shortened and we want to get these books covered sooner than later. I kind of knew that Friday was going to be potential. Let's see where things can. But we'll have to finish this tomorrow and cover the books. You got some answers? You got percentages? Are those percentages? If you're writing a percent, it needs a percent sign. Otherwise, it's a naked number and it will get arrested. Yeah, we don't live in Europe. You gotta wear clothes here.
Yeah, Europe, they're actually very cautious of when they wear clothes.
Well, it depends on where you are, right? I'm not saying everyone in Europe's all.
They don't wear
Alright, purple. What's the first fraction I write out for this? Anybody? 9 over 20. Then, Adrian, what do I do to turn that into something more useful? Times 5 on bottom, which tells me times 5 on top, which then tells me, because now that I'm over 100, Sky? 45%. Joey's sick. Joey, feel better. Nathan, what fraction do I start with for green? 8. You're not Nathan. Your name tag doesn't say Nathan. Thank you, Nathan. 8 over 20. It's amazing how you threw your voice over there and you sounded like Brendan.
It's a gift.
What do I do? Nathan, what do I do? What do I do to the bottom and the top? So I didn't write it out. But up here we had to do times 5 to get to 100, right? Yeah. So both of these get multiplied by 5. Yeah, 40. And that becomes 40%. Orange, first fraction, everybody?
3 out of 20.
Don't all answer at once.
Times 5 equals 100 and 3 equals 6 out of 100.
What?
Sorry. 15 out of 150 Boom. That's easy. That's simple.
Now, are we sure that there's no other colors?
Yes.
No.
No. Maybe so.
No, they can be really small.
Riley, we're not sure, but do these add up to 100? Now, why? How there could be another color on the spinner that we don't know about, but yet these add up to 100. Why?
So there isn't.
I'm supposed to call on you.
Oh.
What? Yes, go ahead.
Sorry. Say that again.
So why, even though there might be another color that we don't know about, and there might, these still add up to 100%. Why isn't that?
Because there are no other colors.
We don't know that for sure.
Well, no, because they don't. It's made out. It's made out of 100%, which is the whole thing is like. Okay,
Careful.
But it's.
What you're saying isn't not true, but this situation is weird because it's a mystery, right, Eva? It's our results. This is 100% of what we did. Here's the problem with experimental probability. The probability you create is just based off what you did. There could be a tiny sliver of another color that we don't know about, and right now we've just said that color has a 0% chance. Just because we don't know of it. You guys have your sketch of your spinner? Want to see if it's right?
Yes.
Now, I about ruined this, and some of you probably saw it as I was looking for the right tab. That's your mystery spinner. So there are only 3 colors,
I knew it.
purple, green, and orange. And those regions are what it actually looks like. So, hold on. Was our probability 100% accurate?
Yes. Yes. No, wait, no.
What did we get for purple?
Purple was 45%.
We got 45%. What did they have for purple? 50. So we actually should have landed on purple a little bit more than what we did. What did we have for green?
45%.
45%? Does that
Oh, yeah,
look like
you had 40%, but we should
40%? Does that look like 40%?
No.
I mean, this right here would be 25. That doesn't look like another 15%. I guess maybe. But no, this is bigger. And if this whole thing is 25%, orange has more than half of this 25%. So we're off, right? Our experimental probability was kind of off. Now, hold up. Anybody have an idea of what we could do? Actually, talk with your group for 60 seconds. What could we do to try to get better experimental probability? Talk with your group real quick.
No. Anyway, so what we can do is do a method time exactly.
You could always go. You always got to do.
Yeah, we were going to take that over to last.
I'm just listening. Well, I would come over there and yell at me to not get your 6.
Yeah. I'm gonna be around a baby this weekend, so I can.
Yeah, that's real concern. That's I think it's a Billy Joel song. Like about moving out. And time. Who's got a really good answer for me? I'm calling on all of you guys today. Anybody I haven't talked with today, have an answer. I'll call on you too. You look like you got an answer.
Who?
No, our back group there. Well, Ava was kind of scared.
I have an answer.
Alana, do you want to share for your group? What did you guys decide?
I want to share.
I know you do.
Then why don't you call on me?
Sophia, help me out. We can do 5 more. Right? 5 more spins. We'll get 25 on the denominator. Still turns into 100 real easy. Layla, what did your group think about? They said do it 25 spins instead of 20. What did you guys say?
I said do more trials.
Do more trials? Did you decide how many?
100. We should just do 200.
Casey says we should just do 100 spins. Who thinks that would be a good idea? Here's what's up. Give me your eyes. Give me your eyes. Pencils down, hands down, give me your eyes. There is a law in mathematics.
Really?
Called the law of large numbers that states when working with chance events, things like we're doing right now, and collecting things like experimental probability, like running statistics, the more times you run the experiment, the closer your experimental probability will get to that theoretical probability. So what that really means is if I only spun this 3 times, do you think I'd get very good results? No. Do you think if I spun it 10 times, I would get better results than the 3 times?
Yes.
Do you think if I spin 100 times, I'll get more accurate results than the 10 times?
Maybe.
Do you think if I spin 1,000 times, I'll get more accurate? Like, as you get more and more and more experiments, you get closer to the accurate theoretical probability. That's the law of large numbers. We'll pick this up right here tomorrow. Pack it up. Please do your homework. So I'm collecting it tomorrow. Have a great night, guys. Hey, this stool is starting to do the same thing as that. It's lowering just slowly, like while I sit on it. Like that was me pulling the thing.
Like this one, when I sit on it, I don't.
Well, it's because you're really light. So how light are you? Like, what's your weight?
60 pounds.
Yeah, you're definitely not. You're barely heavy enough to climb at my gym. The auto voice system might like keep you up top and it would never let you down.